Right, sanbonani. Thanks for tuning in. Lana sizodiscussa iloganji November 2017 question paper chemistry question 3. It's all about the physical properties of organic compounds. Basically, it's organic chemistry. Right. In the description below, uzothola links for amanye questions akhona kule question paper. Right. Let's jump into the question again. Asifunde a statement say to for this question 3 city, the vapor pressure versus temperature graph below was obtained for 4 straight chain or unbranched alkanes P, Q, R, and S, right? And then the second statement city from P to S, each compound nangu P, nangu Q, nangu R, nangu S. So from P all the way up to S, ne? But each compound differs from the previous compound by a CH2 group. Okay, kuyakunikeza a visual picture ukuthi bachaza ukuthini ngale statement lesi ke. Lana sine methane. Prepare 3 ama-logans, ama-structural formulas for ama-alkanes ayi-3. The first 3, which is methane, ethane, and propane. Labo N babukeka ngathi abu R, but this is N and this is N, as well as this one, methane, ethane, and propane, right? So check ke la. Methane in a 1 carbon, ethane in a 2 yama carbons, propane in a 1, 2, 3 yama carbons. So now thatha ukubheka ethane, its previous alkane ubani umethane. So the difference between the two is just CH2. It's CH2. So in other words, bachaza ukuthi if I remove the CH2 kufana nokuthi ngibuyisela kuphi umethane. Or you can look at it this way. If ngifuna ukuthola the next one, I need to add CH2. So kumethane nangabe ngi-add lo CH2 inginikeza u-ethane. Same goes for ethane. Nangabe ngi-add CH2 inginikeza ini i-propane. Or if I remove the CH2 inginikeza ini i-ethane. So every time ngifuna ukuproduce another, each time ngifuna ukuproduce another alkane after i-propane ngiyothola i-butane. It means ku-propane I need to add u-CH bani 2. So the difference between lama alkanes wethu lawa are consecutive. It means like the difference between the two, it's what? It's CH2, right? I hope this makes sense because kubalulekile ukuthi understand nalo, right? Okay, guys, asiqhubeke ne-question yethu bathi the vapor pressures are measured in millimeter of mercury, right? So lama units lawa normally asiwasebenzisi kuma-calculations wethu for high school level, but i-atmospheric pressure sometimes kuyisebenzisa le unit for measuring atmospheric pressure. And then bese babuya bathi the atmospheric pressure is given as 760 millimeter of mercury. This is the graph abakhuluma ngayo. On the y-axis I have what? I have a vapor pressure, and then the x-axis in the temperature. The dotted line represents what? The atmospheric pressure. So okay, now let's jump into ama questions. Ngifuna ukunikeza information eningi before answering ama questions la. 3.1, give a reason why alkanes are said to be saturated. Konje ama-saturated compounds are unreactive. So it means like our alkane saturated because they cannot ama-alkanes are reactor but are not reactive as ama-alkenes nama-alkynes. Why? Because ama-alkanes are saturated because anani? Because they only have single bonds, because they only have single bonds. Alkanes and single bonds, that makes them saturated. This is the reason why are saturated, because of their single bond nature. 3.2, define vapor pressure. Well, I'm trying to provide them definitions, but in this video will provide a definition, and then in the description below as well ngizophinda ngifake le definition engizoyibhala la, right? So now vapor pressure, athi ukuphe another picture, prepare a structure la, ne? On the discussion of vapor pressure. Now imagine two sealed containers, container A and container bani B. Both lama containers lawa are stored at room temperature. Remember, ngifuna ukukunika visual picture of vapor pressure, right? Container A une liquid, ne? I-liquid yakhona inama strong intermolecular bonds, like strong intermolecular forces between ama-molecules wakhona. Angisho siyazi ukuthi ama-alkanes nama-alkynes anama-London forces, which are the weakest intermolecular forces. Then on the extreme end sinama-alcohols nama-carboxylic acids. Ama-carboxylic acids siyazi ukuthi anama strong intermolecular forces. So imagine ulokanje container A having alcohol, for instance. This liquid is an alcohol, and then lama molecules, the forces between them, intermolecular forces wakhona are strong in such a way ukuthi le liquid lena molecules wakhona akaseparate that much easy because of the strong intermolecular forces. So therefore a liquid at room temperature, at room temperature, a liquid, take tatamanzi for instance, abane vapor in a closed container. Ngizokukhomba a container enginayo la erumini lami, ngikhombe yona ukuthi sikhuluma ngani, sikhuluma nge-water nge-vapor pressure. But for now, uma uthatha ukubheka a liquid with strong intermolecular forces, i-vapor yakhona izoba low, the vapor pressure izoba low, meaning ku-vapor sizoba nani nama-molecules amancane, because lama molecules lawa or lama particles lawa akakhona ukuseparate because of the strong intermolecular forces. So therefore izoba nani ne-low vapor pressure, right? And then container B, a sealed one. Remember nale is sealed nakhona, ne? Is sealed. In order to have vapor pressure, you need to seal your container, ne? Even if container yakho ayikho sealed, you still have vapor pressure. But how can you, it's for thina, it's best ukuthi siwasile lawo ma-container in order to measure or understand vapor pressure. Lama particles lawa achincha from liquid state to a gaseous state aya evaporator above the liquid, ne, to exert pressure around the container above the liquid. So since lana sinama molecules amancane, or vapor enama molecules amancane, siba ne result of a low vapor pressure. Liquid B, seal container B in a liquid. In a liquid, yakhona inama weak intermolecular forces. This might be, for instance, alkane, methane, or butane, or whatever, ne? A liquid like this at room temperature, ne? Because of the weak intermolecular forces, lama molecules lawa wa separator by just applying a small amount of energy to that container. Therefore, by doing so, above the liquid siba ne vapor ening, or siba ne gas ening, ne? Siba ne gas ening. So if kuba ne gas ening above the liquid siba nani ne high vapor pressure. One day bengihleli nje yabona, ngihleli ngibhorekile la erumini, so uma ngithi ngiyabheka man, ngishiya amanzi amancane la kule container. I hope uzowabona la, nawa amanzi lapha at the bottom kunamanzi lapha. So uma ngihleli so ngibona le container yami ngathi iyajuluka la phezulu, uyayibona ngathi ijulukile le container la phezulu, even nala emasayidini. Lokujuluka loku kusitshela ukuthi there must be gas above le liquid yethu le liquid yethu at room temperature. Le liquid la ngaphakathi kwalesigubhu at room temperature ikhipha sort of like a gas nyana. So leyo gas leyo igcina seyenzana, seyicondensa around the inside of the container. It shows ukuthi there's a gaseous phase as well as a liquid phase. The gaseous phase i-apply a pressure la. Sometimes unokubona ukuthi nangabe isigubhu samanzi sihleli isikhathi eside wasibeka elangeni, so wasibeka maybe duze nefastera lakho mhlambe li-exposed to sunlight, uthi na uvula le container uyizwa ngathi ithi ps nyana. So yabona, it's because of i-vapor pressure, right? Well, that's the whole concept of vapor pressure. Now, how do we define vapor pressure again now? Define ngale ndlela le. Vapor pressure is the pressure exerted by a vapor in equilibrium. The pressure exerted by a vapor in equilibrium with its liquid. Njengoba ngi-explainile, ubonile lapha ebhodleleni sine liquid ne, and then i-vapor or the gaseous state of the liquid iyo i-exerta i-pressure, and the liquid and the vapor are in equilibrium. In a closed container, but it can be argued that an open container now can also have vapor pressure as well. It can also have vapor pressure. Yeah, nice definition here together. 3.3. With 3.3, here's a question again now. But to use the information in the graph above to answer the following questions. 3.3.1. What is the effect of an increase in temperature on vapor pressure? 3.3.1. What is the effect of an increase in temperature on vapor pressure? Remember, let's go back to this sketch. Now, ngitheni at room temperature ngisho strong intermolecular bonds or forces. If ngifuna ukubreaka lama intermolecular forces lawo ngenzani? If I increase the temperature or apply heat kule container le, what's going to happen above the liquid? Sizoba na more vapor. So because now apply energy onto the container, increase the temperature la, I'm actually trying to overcome the intermolecular forces. So lana if increase room temperature to 40 degrees Celsius, maybe lana maybe kuzoba 40,000 ngiyabekisa kuzoba na 40,000 yama gas molecules or vapor molecules, and then lana maybe kuzoba na 100 times this amount. Why? Because of lama intermolecular forces wala are weak. So just a slight increase in temperature, lama molecules are excited kakhulu, and then are evaporated, right? Evaporated. So an increase in temperature la, but we have to choose from increases, decreases, or no effect. Meaning it's increases. It increases the vapor pressure. 3.3.2. Which compound has a boiling point of approximately 68 degrees Celsius. Give a reason for the answer. Okay. All right. What is boiling point? Before we can even start answering this question, asisibuze yini boiling point konje? Boiling point is the temperature at which okay, about just define a boiling point. Mina define just for the sake of argument or of argument la ule question ka 3.3.2. The temperature at which boiling point angisho. The temperature at which the vapor pressure, so yazi yini vapor pressure ngisho. The temperature at which the vapor pressure is equal to atmospheric pressure. The temperature at which the vapor pressure is equal to atmospheric pressure. Okay again. All right again. Question 18. Which compound? Okay. Asenze so-ke. Now sizofuna a compound with a reach boiling point at 68 degrees Celsius. Lana basiphe ini? Asobheka, this is vapor pressure. So as I go up the y-axis, ngithola ini vapor pressure, or vapor pressure yami yenzani ya increase. So the more you increase, at some point kwamele ibe equal to the atmospheric pressure, and iba equal only and only if one of the graphs intersecta ini the dotted line. So asicke u68 degrees la. 68 degree uyabona ulo kanje u compound S ku 68 degree ne u 68 degree njengoba ngidefinile la, the temperature at which the vapor pressure is equal to the atmospheric pressure is equal to the atmospheric pressure. Okay, yeah, the boiling point, check ala 68 degree. Compound S aga reach a boiling point, because this graph I intersect with the dotted line. Ne? As you go compound R uyam reach boiling point la, where the vapor pressure is equivalent to the atmospheric pressure. But is that temperature 68? No. How about compound Q? Compound Q reach a boiling point la. Is this temperature 68? Possibly, because mawuthatha it's 0, 10, 20, 30, 40, 50, 60, 70, and then this point it's possibly 68 degrees around the lapho. So that qualifies ubani compound Q. So our answer la is what? It's compound Q. Because why? Singathini ke la? Singayiphrase as thini? Compound Q. Why is this? Which compound has a boiling point of 68? Give a reason for the answer. Okay, we compound R because singathi the graph intercepts the dotted line. Maybe ngaqhubeka ngithi mhlambe because the vapor pressure is equal to atmospheric pressure. Atmospheric pressure. Now nasiqhubeka ku 3.3.3. I hope nyenza sense lapha, ne? I hope nyenza sense. Okay. Which compound has the longest chain length? Which compound has the longest chain length? Fully explain the answer. Okay, again. Lana. Siyazi ukuthi from theory that the intermolecular forces between particles in a substance, vapor pressure decrease, especially kuma alkanes, ne? Vapor pressure decrease, the longer the chains, right? The longer the chains, the lower the vapor pressure. So check ala. Compound S at any given temperature. Compound S at any given temperature, ne? Une low vapor pressure. Compared to R, Q, and P, ne? So that qualifies S as the compound with the longest carbon chains. With the longest chains, ngoba vapor pressure yakhe iba lower at any given temperature. So and then yabona increase temperature, vapor pressure yami iba incane. Why? Iba incane because of the intermolecular forces are stronger than PQ and R. So answer to la, I think it's about S. Yeah, in fact to S. I don't think so. S. So but to provide a reason at any given temperature, the vapor pressure at any given temperature, S has a low vapor pressure. Nangaba ubone kahle la ngizoyibhala in the description below as well. So maybe ngathi due to the strong intermolecular forces created by the long chains, maybe not in a lot of energy is a lot of, this sounds informal, sorry, a lot of energy is required to, I think email a phone, a lot of energy is required to break the bonds between the molecules, right? So yeah, iphelela 3.3.3. Now 3.4, but the compound P has 5 carbon atoms. Draw the structural formula of a chain isomer of P. Remember, it's a chain isomer. Write down the IUPAC name of this isomer. Isomers. So it's a 5 carbon chain and the alkane. So original structure la. Boom, boom, boom. 5 carbons. H, 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 H. Yebo? H, 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 H. 1, 2, 3, 4, 5. So lena yini pentane. So isomer for this compound, isomer 9. 1, 2, 3, 4. Ngipha ini a chain. Ngipha a chain, a ethyl chain. No, not an ethyl, but a methyl chain. A methyl chain. A methyl chain. I should say, as with the isomer, it's the same. It's a compound. Nothing. It's a compound with the same molecular formula but different what structure. The formula la yafana nela, but the structures are different. And our properties wakhona engeke are fun. So lana ke bathi sinikeze in IUPAC name yakhona. So lena alkane and then ngine branch lana, so ngizoname my compound as one. Sorry, ngizoname the longest carbon chain from left to right as 1, 2, 3, 4. 1, 2, 3, 4. Why am I naming this compound 1? Because it's closer to the branch. So IUPAC name yalana izoba 1 methyl 1, 2, 3, 4. Now 4 carbon atoms in the longest chain. It's 1 methyl butane. 1 methyl butane. So IUPAC name yalana, it's 1 methyl butane. Okay. Normally chain yakho ungayithatha uyibeke la or uyithatha uyibeke la, it doesn't make any difference la, ne? Doesn't make any difference. So for the last question, 3.4.2, how will the vapor pressure of this isomer compare with that of compound P? Choose from higher than, lower than, or equal to. Okay, now compound P, now the original P, now P, now isomer yakhona. Uyabona ngitheni, the longer the chain, the lower the vapor pressure. But if you are branched, i vapor pressure yakhe yenjani, iba lower. So answer yethu kuzoba lower than. Answer yethu kuzoba lower than. Yeah? Check it. Ngitheni, pentane is longer, so the longer the carbon chain, the higher the vapor pressure. But if iba branched, kuzoba the lower, kumele lower than. How will the vapor pressure of the isomer compare with that of, kuzoba lower than. It's going to be lower than the previous one. How will the vapor pressure? Yeah, it's over lower than P. It's over lower than P. So if video yethu iphelela lana today, in the description below uzothola ama links for amanye ama videos akhona kule question paper. Thanks for watching. Ngizokubona kule video elandelayo. Please consider subscribing nangabe new to my channel. Now we enjoy this video, leave a like, leave a thumbs up, drop a comment in the comment section and let us discuss. Peace.